PreAP Precalculus Notes 9.4 Finding Values of Trigonometric Ratios. For each of the angles theta described below, draw the angle at standard position, find the measure of the reference angle, a positive coterminal angle, and a negative coterminal angle. We've got 1, 2, 3, 4 things to do. Let's find positive and negative coterminal angles first. To find coterminal angles, positive one and a negative one. Coterminal angles are angles in standard position that have the same terminal side. They are complete revolutions apart. So if we take negative 473 degrees and we add to it 2 revolutions, which is 720 degrees, that's going to give us 247 degrees. If we take negative 473 degrees and we add to it 1 revolution, 360 degrees, we're going to get negative 113 degrees. So we got a positive and a negative coterminal angle. Let's draw the angle. $247 is going to fall in quadrant 3. $247 is going to be 67 degrees past 180. So the reference angle, which we're going to call theta prime, 67 degrees. Boom. Number 2. This one is in radians. Let's find a positive coterminal angle. Let's find a negative coterminal angle. Coterminal angles are complete revolutions apart. In radians, every 2 pi is a complete revolution. So if I take 13 pi over 7, and if I add to that a revolution, which is 2 pi, as a fraction, it's 14 pi over 7. That's going to give me 27 pi over 7. If I take 13 pi over 7 and subtract 1 revolution, it's going to be negative pi over 7. That answers 2 of the questions. If I want to draw this, (13 pi over 7) is pi over 7 short of a complete revolution. Theta prime is pi over 7. That's the reference angle. Number 3, different instructions. For each of the angles theta described below, determine the quadrant or axis which the terminal side lies. If no angle exists, state why. Completely explain your reasoning. So let's check this out. Cosine of theta is equivalent to x in the unit circle. And we're saying that's less than 0. Well, if x is less than 0, our conclusion is that theta must terminate to the left of the to the left of the y-axis. Theta terminates left of y-axis. It's the only time x can be negative. Tangent of theta is y over x, and that's less than 0. That means, since it's less than 0, either y is negative and x is positive, or y is positive and x is negative. Those are opposite signs in quadrants 2 and 4. If we combine those 2 answers, of being left of the y-axis and being quadrants 2 or 4, that must mean that theta terminates in quadrant 2. Number 4, cotangent of theta is undefined. Let's do that first. Cotangent of theta is equal to x over y. If that's undefined, that means y is 0. If y is 0, that must mean that theta terminates on the x-axis. If cosine of theta is equal to x, and that's less than 0, then theta terminates left of y-axis. So where in the coordinate plane can we be on the x-axis and left of the y-axis? That's on the negative x-axis. Therefore, theta terminates on the negative x-axis. Sweet, let's go to the back. The terminal side of an angle theta, of an angle alpha, passes through the point given below. Find the exact value of the 6 trig ratios of alpha. I'm going to draw this picture at the bottom and write the answers at the top. So I'm going to figure out what sine of alpha is, cosine of alpha, tangent of alpha, and then the reciprocal trig functions of those. 5, -3, that is in quadrant 4. So I draw my reference triangle using a reference angle. This is alpha. X value is 5, Y value is -3. We don't know what the R value is. This is not a 3, 5, 3, 4, 5 Pythagorean triple, because 5 is not the hypotenuse. Using the Pythagorean theorem, x squared plus y squared equals the hypotenuse squared. So that's 5 squared plus -3 squared is r squared. It's 25 plus a 9er, which is 34, is r squared. If you square root both sides, you're going to get the square root of 34 plus or minus style. The radius is always positive. Sine of alpha. I'm not going to rationalize my denominators. If the directions told me to, I would do it. They don't. I'm just going to leave it. Sine is, let me put this square root of 34 in the picture. Sine is y over r. So that's -3 over the square root of 34. Cosine of alpha, that's x over r. Square roots are getting pretty lazy. Tangent is y over x. And then we got the reciprocals. Cosecant reciprocal of sine, secant reciprocal of cosine, and cotangent reciprocal of tangent. Number 6. Let me cheat here a little bit. I got to figure out what these trig ratios are. -3, -2 is in quadrant 3. So that means the x value is -3, the y value is -2. Figure out what r is. We're going to use the Pythagorean theorem once again. This also is not a Pythagorean triple, so I have to do the work for this. So that's a -3 squared plus a -2 squared equals r squared. That's a 9er plus 4 equals r squared. That's 13 is r squared. So r is plus or minus the square root of 13. The radius is always positive. Sine is y over r. Now, you might be thinking, why don't we just say that sine is y? That's what we were doing before. Well, before it was the unit circle and the radius was 1. The radius here is clearly not 1. So it's y over r. Cosine is x over r. That's negative 3 over the square root of 13. Tangent is y over x. If you divide two negatives, you get a positive. And we have the reciprocals. That concludes 6. Number 7. Suppose that sine of alpha is negative 3/5 and that tangent of alpha is less than 0. Use the information to answer the following questions. In which quadrant does the angle alpha terminate? Well, sine of alpha is equivalent to y over r, which is negative 3 over 5, which is less than 0. Now, r is always positive, so r is the positive 5. That means that y is the negative 3. This tells us that theta terminates below the x-axis. Tangent of alpha is y over x, and that is less than 0. If that's less than 0, then that tells us that y and x have to be different signs to make that negative. Whoops, I left something out here in this previous one. I said terminates below the x-axis. I didn't say what terminates. Alpha. So for tangent of alpha, that tells us that alpha terminates in quadrants 2 or 4. If we combine those two things, our conclusion is that alpha terminates below the x-axis. Which quadrant? 2 or 4 is below the x-axis. It's quadrant 4. Moving on. B, draw and label the reference triangle for alpha and find the exact value of the other 5 trig ratios of alpha. Well, we are told where we concluded it was in quadrant 4. Sine of alpha was negative 3/5, therefore y is negative 3, r is 5. This is a Pythagorean triple, a 3, 4, 5. In quadrant 4, x is positive. So let's figure out what, actually I think I may have had this copied still. Yeah, let's do this. Sine of alpha will be negative 3/5. Cosine is 4/5. Tangent is negative 3 over 4. Then we have the reciprocals. Dunsey. Number 8. Suppose secant of theta is negative 3/2. Tangent of theta is bigger than 0. Part A, in which quadrant does theta terminate? Well, secant of theta is r over x, and we're saying that's positive 3 over negative 2 because r is always positive. If x is negative, then theta terminates left of y-axis. Tangent of theta, which is y over x, is bigger than 0. If y and x, if you divide that and you get a positive answer, that must mean that y and x are the same signs. That tells us that theta terminates in quadrant 1 or 3. So what's left of the y-axis? Quadrant 3. Therefore, theta terminates in quadrant 3. B. Let's draw and label the reference triangle and then find the trig functions of those little fellas. So let's do that. So we are told that secant of theta is -3/2, and we concluded we're in quadrant 3. So we have a reference triangle. So we know that R is 3 and that X is -2. Don't know what Y is. This is not a Pythagorean triple. So we use the Pythagorean theorem. We're going to end up with y squared is 5, so y is plus or minus 5. So is it plus or is it minus? Pardon me, plus or minus square root of 5? Is it plus or is it minus? Well, we're in quadrant 3. We had to go down, so it's negative square root of 5. Sine negative square root of 5 over R3. Cosine's -2/3. Tangent would be square root of 5 over 2. Divide two negatives, you get a positive. Then we have reciprocals. And we're finished. Oh, another one. DJ Calla must be in the house. Number 9. Number 9 is pretty much the same as 8, so I'm going to go ahead and skip that. If you want to see the answer to that, then check the website for the handwritten answer key. Let's go to 10. Terminal side of angle beta, that's a funky looking beta, lies in quadrant 2 along the line 2x plus 5 is 0. Order the values of sine of beta, tangent of beta, and cosecant of beta from least to greatest. Well, let's start with a picture. Actually, we start with a picture, I want to know what this line is going to look like. If I get it in slope-intercept form, I get a y-intercept of 0 and a slope of -2/5. So if I start here at 0 and I go up 2 and to the left 5, here's what I know for certain. The ordered pair, -5, 2, has to be on this line. I know you could be thinking, well, what if I wanted to go left 10 and up 4 and use the ordered pair -10, 4? You can do that as well. So everything's going to reduce to the same thing. If we draw our line, or pardon me, our reference triangle for this, we know what x and y are. We don't know what the hypotenuse is. This is angle beta. So if we use the Pythagorean theorem, again, this is not a Pythagorean triple. X is -5, y is 2, don't know what r is. When I get in a hurry, I write super sloppy. And when I write super sloppy, I have to correct it. So when I get in a hurry, it takes more time, sadly. R is always positive, so the hypotenuse is square root of 29. Order the values of sine of beta, tangent of beta, and cosecant of beta from least to greatest. Well, sine of beta, that's going to be 2 over the square root of 29. Cosecant of beta is the reciprocal of that. Now, without a calculator, the square root of 29 is 5 point something. So I have 2 divided by 5 point something, or 5 divided by 2 point something. So this one is bigger than this one currently. Then I have tangent of beta. That is y over x. Well, that's negative. This is clearly the smallest. This is the biggest. And this is the middlest. The directions, order them from least to greatest. So tangent of beta followed by sine of beta followed by cosecant of beta. (11) Suppose tangent of theta is -4/3 and secant of theta is bigger than 1. Find the values of cosecant and cosine. Well, if tangent of theta is equal to -4/3, we don't know if the negative goes with the 4 or the 3. Couldn't go either way. Keep in mind, this is y over x. If that's less than 0, then that tells us that theta terminates. I told you, when I get in a hurry, I write so much more sloppy. It takes more time. It's going to fall in quadrant 2 or 4, because in quadrant 2, the signs are different, and in quadrant 4, the signs are different. Secant of theta is r over x, and that's bigger than 0. So that tells us that theta terminates right of the y-axis. What can we conclude from that? Well, if it's in quadrant 2 or 4 and it's right of the y-axis, only quadrant 4 is to the right. So let's draw this. We know now that y is the -1 and x is positive. Hey, this is the Pythagorean triple. It's a 3, 4, 5. The hypotenuse is always positive. Cosine of theta would be 3/5. Cosecant of theta would be 5 over -4. Well, that concludes the notes. I know I skipped number 9, but I think we did plenty of examples of those. Please do the homework assignment that accompanies this and have a merry, merry, smiley day.